The surface of Mars, as seen in this observation, is littered with examples of glacier-like landforms. While surface ice deposits are mostly limited to the polar caps, patterns of slow, viscous flow abound in many non-polar regions of Mars. Streamlines that appear as linear ridges in the surface soils and rocky debris are often exposed on top of infilling deposits that coat crater and valley floors. We see such patterns on the surfaces of Earth's icy glaciers and debris-covered rock glaciers. As ice flows downhill, rock and soil are plucked from the surrounding landscape and ferried along the flowing ice surface and within the icy subsurface. While this process is gradual, taking perhaps thousands of years or longer, it creates a network of linear patterns that reveal the history of ice flow. Later and under warmer conditions, the ice may be lost through melting or sublimation, where ice evaporates directly from solid to gas without the presence of liquid. Rock and minerals concentrated in these long ridges are then left behind, draped over the pre-existing landscape. NASA's Perseverance Mars rover recently took a self-portrait against a sweeping backdrop of ancient Martian terrain at a location called Lac de Charmes. The selfie shows Perseverance training its mast on a rocky outcrop on which it had just made a circular abrasion patch, with the western rim of Jezero crater stretching into the background. The selfie was captured on March 11, 2026, during the rover's deepest push west beyond the crater. Perseverance is in its fifth science campaign, known as the Northern Rim Campaign, of its mission on the Red Planet. The Lac de Charmes region represents some of the most scientifically compelling terrain the rover has visited. Perseverance took the selfie when the rover entered a remote, untamed region beyond the Jezero crater rim dubbed Wild West. This is the farthest west the rover has been since it landed at Jezero a little over 5 years ago. The rover had just abraded and analyzed an outcrop, and the rover was sitting in a spot that provided a great view of both the Jezero rim and the local terrain outside of the crater. During abrading, the rover ground down a portion of the rock's surface, allowing scientists to analyze what's inside. The technique enabled scientists to determine that the outcrop is composed of igneous minerals that likely predate the formation of Jezero crater. Igneous rocks with large mineral crystals form underground as molten rock cools and solidifies. Perseverance acquired the selfie, its sixth since landing on Mars in 2021, using the wide-angle topographic sensor for operations and engineering camera mounted at the end of its robotic arm. This view of the Martian surface, captured by NASA's Psyche spacecraft on May 15, 2026, shows streaks that have formed due to wind blowing over impact craters in the Valles major region. Valles Major Planum, a massive, shield volcano spanning roughly 1,000 by 1,500 kilometers, is located within this region. The volcano is historically famous as the first surface feature ever documented on another planet, initially sketched by Christian Huygens in 1659. Originally mistaken for a plane, it was later revealed by data from the Mars Global Surveyor that Valles Major Planum is actually a broad, low-relief shield volcano formed by ancient, highly fluid basaltic lava flows. The feature appears as a prominent dark spot on Mars because its basaltic volcanic rock is relatively free of the bright dust that covers much of the planet. Early astronomers had also noticed that the shape and darkness of Valles Major frequently changed. Spacecraft data has since revealed that these shifts are caused by wind and dust storms. Winds blowing across the equator move bright dust and sand over the dark volcanic surface, altering its appearance over time. The wind streaks seen in this observation extend to about 50 kilometers long, and the large craters near center bottom of the scene average around 50 kilometers in diameter.